that planning, work, and scheduling is extremely complex with all these different products. So they're non-standard, they're pretty much all one-offs. And you've got over 120 work centers all competing for the same work. Now, in our context, we're flat out. We cannot get enough out the door. It's been that way for the full almost 8 years that I've been there. And just to give you some numbers, our average throughput through Bassendean is 10 million a month. And to satisfy all that are interested, we've got to do 14. And that's at least for the next 6 months. So it's a big challenge. How we're going to adopt and implement the technology, we just touch on theory of constraints. And there's a hypothesis that any complex system, like our manufacturing system, it consists or is broken down into a series of linked activities. Only one or two of those activities is actually limiting the whole process. And what you're limiting is your throughput, it's your dollars, your revenue, your earnings, anything you define it to be, but it still comes down to your dollars. Once you've identified the bottleneck, you need to exploit it. Now, this is where we are in our journey in using sensors and the Internet of Things. Exploit it. Now, what it means at this step is you don't spend money, right? You make the most of what you've got. You don't invest. You actually go and investigate what is holding up this process. So at Hofmann's, it's our gear grinding area. It's 4 machines. 3 of them are full-scale production machines, and one is a little bit bigger that's not used very often. So we know that from our ERP system. There's 12 months loading on these machines right now. So if we did nothing, we got no other sales, we got 12 months of work for these machines. It's clearly our constraint. So the beauty is if we improve this constraint, we'll improve our throughput, dollars will go up. How do we measure machine utilization? Now this is what we actually did. This is a gear grinding machine. This wheel does the work. It cuts the teeth to a very accurate form on the gears. And here's our little sensor, Coriat sensor that we've put on the head. Now some very clever engineers that are also in the room, they came out. And within an hour, we had the sensor on and we had our operators running up and down the gear tooth at full in-feed, full actual speed. The guys recorded the signal, we set some bands, and we said, that's fully utilized. So again, I'll just emphasize, full in-feed, full cutting speed. Everything else, a signal that's not that, is something else. One thing I love about this product is the menu there you can choose. I'm an administrator on this, so I can choose what menu's on there. And the way we use it is those little menu buttons there are the guy's language. So the machinists who are running the machine, it's their language. When we were installing this, we had a loss. You get an app with it as well. It'll ping you on the mobile phone. But when there's a loss, we went down and asked the guys what was happening. Up there, just an example where operator busy, he says there's 2 on these 3 machines. He was off on holiday, I was busy. Right, operator busy, it goes on there. It's the guy's language. Right? It's intelligent, they can relate to it. Another example, there was no jobs, which is rare, but there was no jobs, so that goes on there, no jobs. And from that, you get some pretty funky reports coming out. So this is just a display, the portal. Green is good. Everything green is good. It's running at full speed, full in-feed, creating the most value at the minimum time. And then you can color everything else to your choice based on the operator's word. Now I can convert their language to OEE. It's just fine. It doesn't really matter. You can pull your mouse over any day or any hour. It has a backlog of months.